Hello algebra students, we are going to continue reviewing systems of linear equations. So, solving systems of linear equations. And then I'll get rid of the fancy ink. Alright. So remember, we have multiple methods. I have a video that I just posted with this one where we can solve using the equal values method or the graphing method. And both of these, remember, have the same setup where we have y equals an expression for both equations. Okay? Then we have two additional algebraic methods. We have the substitution method. Substitution. I have to say it slow so I can spell it. And then elimination. So this is really what I want to focus on today in this video. So let's take a look at an example where we would use substitution and an example of when we would use elimination. So I'm just going to write out the systems here. I'm not going to solve them yet so that we can just do some comparing. Okay? So if I'm going to solve using substitution, I am generally going to have one equation that is a y equals or an x equals, and then a second equation that is not. So for example, I might have one that is, let's see here, y equals 4x plus 18. And then my second one might be negative 4x minus y equals 14. Okay, so when I have this y equals, what I can do is take what the y equals and replace it in the second equation. That's our substitution. We substitute an expression in for a variable so that we can go from two equations with two variables to one equation with one variable. Okay? A nice example of the elimination method would be something like this, where we have both equations in standard form. Okay, so negative x minus 4y equals 2, and then 9x plus 4y equals 14. Okay, so what we're looking at here is two equations in standard form. Okay, and here's what I want to point out to you. Our y's are the same but have opposite signs. Another scenario may be a case where you can make them similar. You can make them the same by multiplying by a constant all the way through your standard equation. Okay? So when that's the case, if we add these together as is, this eliminates one of our variables, and so we're still going from two equations with two variables to one equation with one variable. Okay, so that's what we need to take a look at. Look at your structure. If you have a y equals, use substitution. If you have one y equals, if you have two y equals, then you're going to do your equal values or graphing. Okay. But here, if you have one equation that's set up in y equals mx plus b and the other not, that's a great case for using the substitution method. If you have two equations in standard form, then that's a great case for using the elimination method. Okay, so let's see what that looks like. Okay, I'm going to go ahead and clear this out. If you ever need to pause and fill in some notes, do that. That's why we have these videos for you. Okay, so let's take a look at, let's look at that one I just had up. So negative x minus 4y equals 2, and 9x plus 4y equals 14. So I'm going to notice my structure, two equations in standard form. Okay, so this guides my thinking to the elimination method. All right, so what I'm going to do is look at my values here with my y's, negative 4y and positive 4y. If I add those together, those eliminate. Negative x negative x plus 9x is positive 8x, and then 2 plus 14 is 16. So then I can continue the process of solving for x by dividing. X equals 2. Pretty straightforward there. So now all I need to do is go back and find the value of y. And I can do that using either of the two original equations. So do I want to use negative x minus 4y equals 2 or 9x plus 4y equals 14? It doesn't matter. So I'm going to go with the one with positive coefficients. Okay, and I'm going to put in 2 for x. So 9 times 2 plus 4y equals 14. 9 times 2 is 18 plus 4y equals 14. Then I'll subtract 18 from both sides, and we get 4y equals negative 4. Divide by 4, and we get y equals negative 1. But again, that's not my total answer, because my answer, my solution, is the ordered pair. X comma y. So in this case, that is 2 comma negative 1. Okay? So that was our elimination method. Well, what happens if something doesn't line up and eliminate right away, but it's still set up in that standard form process? Well, let's take a look. Okay? So I am going to look at 2x minus 6y equals 28, and negative x minus y equals 14. So here, if I add these together, 2x minus x is 1x, and negative 6y minus y is negative 7y. I'm still left with two variables. So here, we're in standard form, but we have no matching coefficients. So that means we need to multiply first so that we can use elimination. Okay? So what I'm going to do is look at this 2x minus 6y equals 28 and negative x minus y equals 14 and ask myself, okay, what can I do to my bottom equation to make one set of my variables match? So maybe I start with my x's and I think, you know what, if I multiply everything by 2, then I have positive 2x up here and negative 2x down here. That might work. So let's try it. I'm going to rewrite my first equation. 2x minus 6y equals 28. And then I'm going to distribute this 2 all the way through my bottom equation. So 2 times negative x is negative 2x. 2 times negative y is negative 2y. And 2 times 14 is 28. So now, when I add these equations together, come on, plus, there we go. When I add these together, my 2x and negative 2x eliminates. Negative 6y and negative 2y is negative 8y. And 28 plus 28 is 56. So now I divide by negative 8, and I get y equals negative 7. Now remember, I'm not done yet, because I need to go back and find the value of x. It does not matter which equation we go back to, so maybe I do the one negative x minus y equals 14, because I think I don't need to technically do much dividing with that maybe. So, but again, it doesn't matter. So if I take that negative x minus y equals 14 and I put in negative 7 for y, I'm going to pay attention to my positives and negatives. So negative x plus 7 equals 14. Subtract 7 from both sides, and we get negative x equals positive 7. So remember, when I don't have a coefficient listed in front, it's technically a 1. So this is negative 1 times x. So I'm going to divide by negative 1, and we get x equals negative 7. So if x equals negative 7 and y equals negative 7, maybe I want to double check. 2 times negative 7 minus 6 times negative 7, that's what, negative 14 plus 42, is that 28? Yeah, it is. So that works. Okay, so my solution is negative 7, negative 7. Okay, so now let's work one more example, and that is our substitution method. So let's go back and look at that second example from the beginning of the video. Okay, so let me clear this out. And we are going to look at the system y equals 4x plus 18 and negative 4x minus y equals 14. And then I'm going to again look at this slope-intercept form, and I've got my y here and here. So we are just going to replace. This 4x plus 18 is going to go where the y is. So negative 4x minus, and I'm going to use parentheses so I can keep everything nice and clean. Because what I need to do is remember that I have a negative 1 here. So I need to distribute that negative 1 all the way through. So negative 4x, negative 1 times 4x is negative 4x. Negative 1 times 18 is negative 18, and that equals 14. Okay, so now I'm going to combine my like terms. Okay, negative 4x and negative 4x is negative 8x minus 18 equals 14. And now from here we're going to do the same thing on both sides of our equation. So I want to get the x by itself, so let's add 18 to both sides. Negative 8x equals 32. Divide by negative 8. and x equals -4. Remember, we're not done yet because we need to go back and find the value of y. And this nice equation up here on top that already has the y equals for us is the perfect setup to do that. So I'm going to replace the x with -4, and then add 18. So y equals 4 times -4 is -16 plus 18. Y equals 2. Okay, so then my solution is the ordered pair -4, 2. And I can double check that down here. -4 times -4 is +16. Minus 2, 16 minus 2 does equal 14, so that does work. That is our solution. Okay, so hopefully that helps you differentiate between elimination and substitution, gives us a little bit more practice solving using those methods, and then if you have further questions, make sure you email me. Okay, see you later.